Um, these next sections talk about some more specific types of compounds. Ceramics, different kinds of ceramics, different types of silicate ceramics. So these can have aluminum and silicon and oxygen in them, and then you can get different properties by varying the ratios. When you heat, these are formed by heating the ingredients, etc. In essence, so you've got these clays that are formed naturally, and you mix that with water, and then heating causes a reaction that covalently bonds the atoms within that and forms a ceramic. So there's different kinds of clays that will give you different sorts of silicate ceramics. You can have oxide ceramics with no silicon present, aluminum and oxygen, or magnesium and oxygen. And they're going to have different types of properties. You can also have non-oxide ceramics where there's no oxygen. Si3N4, Bn, SiC. And again, these are useful for lots of different things. Cement, invented by the Romans or discovered by the Romans. So they mixed all this stuff together, lime, volcanic ash, and clay with water, and you could pour it, but then when it dried, it's not like Play-Doh or something that just gets hard when it dries out. It actually undergoes a chemical reaction. So there's different types of cement. Portland cement is a well-known kind. So it reacts with water, and there's a series of chemical reactions that produce the hardened result.
It gets warm. It gets warm when
It probably does get warm, yeah. It's probably an exothermic reaction. Concrete is different than cement. Did you know that? Concrete is a mixture of cement with sand and often pebbles. And it's the most widely used building material in the world, and it revolutionized construction, because instead of trying to build things out of solid rock, it's really hard to move around and break into the correct size pieces, or wood or metal. Concrete is very easy to form structures out of. Glass is another one of these network covalent solids. If you take silica and melt it and then cool it quickly, it will form an amorphous structure that we call glass. And there are different types of glass depending on what exactly is in them. So silicate glass is great for windows and drinking glasses, but it takes a really high temperature to form. The Romans, again, were the first to develop glass making. So they found that if you added sodium carbonate to the silica, you could reduce the melting point. 1500 degrees is a bit difficult to work with. So you put sodium carbonate in there, now it'll melt at a lower temperature, so you can, melt it even with like a Bunsen burner. You can blow it and make it into all kinds of shapes. Other types of glass include vitreous silica or fused silica. This is really hard, resists high temperatures. It's really expensive. Soda lime glass is the most common type. This is mostly silicon oxide or silica, but then it also has sodium and calcium in there. This tends to crack under thermal shock. So this is a sort of glass that if it's cold and you put it on a hot surface, or it's hot and you put it on a cold surface, it'll just crack. Borosilicate glass, and the trademark name is Pyrex, has boric oxide in there instead of calcium oxide. And this gives it a better heat expansion. It expands less when heated and cooled, And so Pyrex glass, which is what our test tubes and beakers are made out of, you can heat them and set them on the counter and they're not going to shatter. A regular soda lime test tube, which we do have some, if you try to heat those in a Bunsen burner, a lot of times they'll shatter, they'll crack. So things that you heat, you always want to have them be Pyrex. There's also leaded glass that has lead in it. This is more brilliant. It's got a shinier appearance. It'll make a ringing sound when tapped, but if you're storing your alcohol in a leaded glass decanter or you're drinking out of leaded glass goblets or whatever, the lead can leach into your food and that's not good for you. So they have created lead-free crystals as well.